So now we're going to shift our attention over to network security tools. Now, when it comes to network security tools, I want you to realize that we're not here to teach you how to use these security tools. So we're going to cover a lot of these different tools just here on slide, but we have put together a video, multiple videos, I should say, with demonstrations on these different tools. So if you're interested in digging a little deeper into these tools and learning a little bit more about them and seeing them in action, then in your campus environment, underneath Security Plus, if you scroll down, so I'll go back to the top so you can see. So underneath the course for Security Plus, if you scroll down, keep going down, you're going to see additional content, demonstrations, and tools. And so there's a lab set up, so you don't have to do that, but absolutely you can if you want to. But then there's Nmap, Netcat, Netstat, Cat, Tailhead. Now, a lot of these we're not even going to be covering. chmod, grep, dd, wireshark, hping, metasploit, and then even some stuff on SQL injection, cross-site scripting, cross-site request forgery, scanless, curl, even an SSH honeypot. So you can go through these at your own leisure whenever you want, just to get a little bit more information about a lot of these if you want to. But for the certification exam, your goal is to be prepared for essentially picking them out of a lineup. So if they ask you, you want a tool that does this, then simply know that that tool can do that. And that's what we're going to do here today. Because if I sat back and demonstrated and taught you about all these tools from beginning to end, we'd be here for 3-4 sessions going through all of these different tools. So it's about making sure that you are prepared to understand, why would I use this? What does it do for me? And that's it. Whether you know how to use it or not, that doesn't matter for this certification exam. So here we go. Ping. We should all be familiar with ping. If you're not, that's all right. But what does a ping command do for us? It simply sends what we call an echo request to some type of destination machine that we define. And what is the whole purpose of ping? To determine if end-to-end communication is possible at what we call layer 3. Because we're just simply using IP addressing here. Can I ping your IP address for me? And if I can, that means layer 3 of the OSI model, layer 2 of the OSI model, layer 1 of the OSI model functions, meaning I have layer 3 connectivity to you from an IP addressing standpoint. Now, if the application for me to you is still not working, well, then that means we probably have an application layer problem. Or maybe we even have a transport layer problem in that case. Maybe we're using TCP instead of UDP, or we have the wrong port numbers, whatever it is. Ping is just there to say, hey, do we have basic layer 3 connectivity with each other? Now, you can take ping a little bit further. For example, you can change the size of the actual ping packet. Most devices default the size to 100 bytes, but you can get all the way up to 1500 bytes if you want to, even higher on some implementations of ping, but you can specify the size. You could even specify any type of service markings or things like that, so you can mimic, pretend it's like a voice packet, or pretend it's maybe a video packet based on quality of service markings. And then you can even set things like the do not fragment bit. So by manipulating with it, you can figure out things like, will I be able to successfully get from point A to point B on layer 3 if it's like a voice packet, or if it's like a video packet, or if it's just a regular data packet? You can even check what the maximum transmission unit is along a path with ping. Because if you set the packet size to something like 1500, you set the do not fragment bit on, then when the ping happens, if any of those interfaces along the way that the packet is going through has a maximum transmission unit that is less than 1500 bytes, well then, since you have the do not fragment bit set, that router is going to respond back to you saying, hey, I can't fragment. And then you're going to know that the maximum transmission unit has been breached. So you can figure out the MTU that way along the path. But for the exam, right, let's keep it simple. Ping, we can send probes, echo requests to a specific destination machine to determine if communication is even possible with them. Path ping is going to take ping beyond what it is. So with path ping, we have this TCP/IP based utility that is going to display your path that the actual packet is taking. So with ping, you don't get to see the path the actual packet is taking, but with path ping, you can. So it's like as if you were using traceroute or traceRT. But then path ping can also calculate the loss information and everything else that you also get with ping. So path ping is a combination of pinging as well as tracing the path from beginning to end. And then we have trace RT and trace route, which is just about tracing. So trace RT is a Windows command for tracing the route that packets take over the network. So it's going to provide a listing of every single router hop that the packet goes through from source to destination. So that way there you know which way through the network the actual packet took. Because then you can reference all those values that it returned, and you can go and see, okay, that's this device and that 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 device along the path. So you'll know the exact path it's taking through the network. It uses ICMP. So it's like ping. And if ICMP is blocked, then traceroute fails. Just like if ICMP is blocked, pings can fail. On Linux and Mac operating systems, we have the traceroute command. So that's where traceroute comes in. So Windows, Linux, Mac. So they display the route a packet takes to a destination, recording the number of hops along the way. So any scenario that says you need to trace the path to find out exactly which way the path is taken, I'd choose traceroute or trace RT. The odds of you seeing path ping and trace RT and trace route in the exact same scenario is next to none, because that would be an unfair answer option, because, well, they both do the same thing essentially, except unless they turn around and they're trying to trick you. You also want to get the results related to like round trip time of each and every single packet. Well, that's something that path ping can do for you, because that's a ping feature. You want to be able to calculate loss information. Well, that would be path ping. While tracing the path, that would be path ping. Or traceroute doesn't do that. HPing is a TCP/IP packet creation tool. That's what it is. A packet creation tool that allows a user to craft IP packets, TCP packets, UDP, ICMP, all from scratch. So what does it give you to do? It gives you the ability to simply perform any range of network operations that you possibly could with IP, TCP, UDP, or ICMP. So anything you do with any of those protocols, you can actually craft into some type of packet here for testing purposes. So HPing not only checks connectivity from a layer 3 standpoint, but when you think about the fact that you could craft a packet that is maybe TCP based and has certain port numbers listed in the TCP headers, then you're also be able to do port scanning, because you'll be able to identify if a particular port is open on that particular destination device. So do I have connectivity to that particular port number? So you can do host discovery as well with HPing. Host configuration commands and host status commands. ifconfig, ipconfig, IP, and netstat. So ifconfig and ipconfig. So ifconfig is for Linux, ipconfig is for Windows. Command line tools to verify and manipulate the network interface parameters on your devices. So we can list the interfaces, we can list the connection parameters, we can even alter the parameters using these tools. We can release and renew DHCP connections as an example. So if you're having any type of network connectivity issues, these are tools that you can utilize to verify the actual network configuration, the network setup of your network interface card on that particular operating system. Now, the IP command is a Linux-based tool, and that tool is going to be used to show and manipulate information pertaining to routing and policy routing and any tunnels that you might have set up on that particular Linux device. Now, netstat is a command that we can utilize to monitor the network connections that have been established to and from our system. So if you want to know how many, for example, TCP sessions that are currently active or established on your device, you can use netstat to do so. So the command like netstat -a. So if I typed in netstat -a at the command prompt, netstat -a, that can give me, for example, a list of all active connections and their listening ports. If we do netstat minus AT as an example, we could list all active TCP connections. If we did netstat AN, then we could list all active UDP connections. So netstat is a tool that provides us with a listing of all network connections that that particular device has at this point in time. So we'll be able to tell which IP addresses they're going to, which ports are being used right now for the different connections. So which ones are established, which ones are in a listening state right now. So let's say you're under an attack whereby the cyber criminal has opened a whole bunch of half opened, I should say, TCP sessions with you. So what they've done is they send the SYN packet, you've sent back the SYN-ACK, but they don't acknowledge that. So you are in the listening state waiting to fully establish, but they never respond back. Why? Because they're trying to consume all the available slots you have for TCP connections. Right? They're trying to cause a denial of service attack in relation to TCP on your device. Well, if you're wondering if that's what's going on, because your server's not responding, if you type in netstat, you'd be able to see the IP address, the source IP, the ports that are being used, all these half-open connections in the listening state at this point in time. So it's a great way for you to get a listing of all the connections you have or partial connections that you have on your device. From a DNS standpoint, we have NSLOOKUP, DIG, DNS enum, enumeration, that's what that is. So NSLOOKUP is a tool that you can use to query DNS. So DNS, as we talked about earlier, is what? Used to convert a human-readable domain name into an IP address. So you type in www.stormwindstudios.com in your web browser, DNS gets you the IP address. All right, so DNS is not a single system. It's a hierarchy of servers. We got root servers, backbone servers. Your service providers have servers. Right? Your home router can be a DNS server as well. Even your local machine has a host file. So that way there it can check the local host file cache first before it goes ahead and contacts a DNS server. So if you need to examine details about a certain DNS query for a very specific address, you can use the NSLOOKUP command to obtain the mapping between the domain name and the IP address or any other DNS records associated with it. And DIG is a Linux version of that. So NSLOOKUP is a Windows version and DIG is a Linux version of that same thing. Now, DNS enum, so DNS enumeration, is actually a Perl script designed to enumerate DNS information. So when we talk about enumerating DNS information, we're talking about getting things like the entries, the subdomains, the MX records, the IP addresses, and a whole lot more. Right? It's about getting a laundry list of everything associated with, for example, www.cisco.com. Right? I want to know cisco.com. If I'm using DNS enumeration, it's going to give me everything it can possibly find about cisco.com. I can get all the public DNS entries for that given domain name by using DNS enumeration. So yes, I'll be able to get a listing of all the publicly available resources that exist on the internet for that particular domain name. And it also interfaces with other tools, like, for example, the Whois tool. And therefore, with the Whois tool, we can gather additional information. And therefore, we can even get information about usernames and owners and who to contact information as well by using DNS enumeration. Traffic analysis. How many of you have used Wireshark? Very cool graphical user interface tool. When it comes to traffic analysis for the exam, TCP dump, Wireshark, what are these? Well, TCP dump and Wireshark are traffic capture and analysis tools. Traffic capture and analysis tools. So any scenario about capturing traffic and analyzing it, what tool could you use? TCP dump, Wireshark. There's WinDump, Packet Square, CapEdit, Ethereal, different things like that. But these are the two I want you to know for the certification exam. So TCP dump is command line based. So if the scenario is command line based, then your answer is going to be TCP dump. But graphical user interface, any type of scenario, that is going to be Wireshark that you're going to pick. So they both can create and analyze what are called PCAP files. So that's something you might want to remember for the exam. Any scenario that's talking about PCAP files, or if they have a file that ends in PCAP, so the extension, so you have some sort of file name followed by .pcap, then I want you to realize they're talking about traffic analysis here. They're talking about TCP dump. They're talking about Wireshark. That's where you want to shift your attention to when answering the question. So they both can create and analyze these PCAP files, which are packet capture files. And if we want to use a command line tool, TCP dump, but if you want to use a graphical user interface tool, then Wireshark is the way to go. And Wireshark is the most popular graphical interface tool out there when it comes to traffic analysis today. So even though the certification exam objectives say that it's vendor neutral and they will not test you on specific products or services, well, I mean, Wireshark is a really great traffic analysis tool, and as a security professional, you should know about it no matter what. So I guess it's all right for them to test you on it, even though they might say you don't need to know anything about it. The key here is you're not going to have to know how to use it. You just have to know what it's for, like we've been talking about with a lot of these other things. All right, some honorable mentions, just to wrap it up in case they show up on the exam. Number 1 here, Sniper, or SN1per, however you want to put it. A Linux-based tool used by pen testers. So this is a penetration tool. It is an automated scanner, all right? Sniper equals automated scanner. For what? To collect a large amount of information while scanning for vulnerability. So this is all about vulnerability scanning. So we have these scripts to enumerate servers, their open ports, their vulnerabilities, just to name a few. And then it can also brute force these as well. So whatever it finds, it can brute force the open ports, brute force subdomains, brute force DNS systems. It can scan web applications for common vulnerabilities. It can even run targeted Nmap scripts against open ports, as well as even targeted Metasploit scans and exploit modules. So Sniper is actually can be incorporated in some other services and platforms and tools like Nmap and Metasploit. So when it comes to automated scanning for vulnerabilities, Sniper could be an option on the exam, right? Linux-based. Now, the Harvester is a Python-based program for penetration testers, right? Harvester. When you're harvesting, what are you doing? You're gathering. Harvesting equals gathering. So this is what it's about. It's about gathering information during reconnaissance of pen testing. So that's typically when you're going to use Harvester. Gathering information during reconnaissance. So it's a useful tool for exploring what is publicly available out on the internet about your organization. So on the web, what's out there? Can provide information on employees, emails, subdomains, different public sources such as search engines, right? Even Shodan databases. So definitely the Harvester on the certification exam would be your answer if they are talking about gathering information during the reconnaissance portion of penetration testing. Whereas Sniper would be about the automated scanning of large amounts of information pertaining to systems and their vulnerabilities. Scanless, command line tool to interface with websites that can perform port scans. Right, so command line tool used for port scanning. Again, part of penetration testing. So when you use this tool from wherever you are, the source IP address for the scan is not your machine. It would actually be the website you're trying to scan from. So not your actual testing machine. So it's written in Python, it has a simple interface, and since it's scanless, it anonymizes your port scan as well. Curl is a tool designed to transfer data to or from a server. So curl is a tool designed to transfer data to or from a server without user interactions. So it supports a long list of protocols, and you wouldn't have to know the long list of protocols for the exam, but dict, file, FTP, FTPS, Gopher, HTTP, HTTP, blah, 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 et cetera, et cetera, et cetera, and the list is way too long. Think of it like a Swiss Army knife, curl, for interacting with a server. Originally, it was designed for interacting with URLs. So curl is commonly used on Linux-based servers in AWS when you're interacting with the various URLs in other areas of the AWS environment. But it's expanded beyond that, curl, to be essentially a jack of all trades tools supporting the numerous protocols, some of which I mentioned, including SMTP, Telnet, TFTP, POP, and so on. And it works both on Linux and Windows operating systems. So for the exam, to keep it simple for yourselves, if the scenario is talking about transferring data to or from a server without user interactions, and you're using a command line interface and potentially URLs are involved with it, then curl is going to be your right answer. And then lastly, we have Nmap. Nmap is used to discover what systems are on a network. Nmap stands for Network Mapper. So it's a network scanner. So what are we scanning for? We're scanning for the systems, the ports that are open, the services that are running on those systems. We can do OS fingerprinting with it. We can find rogue devices. Therefore, we can discover other services and applications that are running and potentially the versions of them. It's a command line tool, so it's super scriptable. But there is a graphical user interface version of it called ZenMap, Z-E-N. So what is it? Z-E-N-M-A-P is the graphical version tool of it. Windows, Linux, Mac OS, all supported. Right? So if any scenario says you need to locate all servers in a particular subnet that respond to a certain protocol, and or you need to fingerprint your servers, Nmap is what you would pick in that case. You're probing your computer networks. You're doing host discovery. You're finding out what they're running. So you can even get advanced detection like vulnerability detection and other features as part of Nmap. All right, so like I said, it's about, can you quickly pick them out of a lineup? Simple scenarios. Do you know the difference between harvesters, Nmap? Do you know when you use ping versus traceroute, or maybe path ping? Do you know what Wireshark is? Do you understand what a PCAP file is? And right, packet capture file has all the packets that are captured in it. And you can open it up in Wireshark and analyze it. Different things like that. Yeah, Brian says Nmap is the most amazing tool in the world. And yeah, I pretty much have to agree with that. So you'll see here that some of the ones we covered are listed in the additional demonstrations and tools section. So Nmap, right at the top of the list, folks. I'd encourage you to absolutely watch that one. Definitely watch that one. Watch DD, because we'll talk about DD later. Watch Wireshark. Watch HPing. Take a look at some of the SQL injection, cross-site scripting, because we talked about it earlier in a previous session. So those are good demos as well. Scanlist, curl. Right, take a look at some of those. Right, just to help you out. All right. So again, you don't have to know how to use them on the exam, but you definitely have to know how to pick them out of a lineup.